Hi, I'm Spencer Krause. I've been building robots for over 20 years. In that time, I've seen a lot of interesting things, and I've heard a lot of interesting stories. Collaborative with Spencer Krause is a place where my peers and I can relax, have a drink, and talk about some of the crazier things we've seen at work and some of the experiences we've had that have gotten us to where we are today. Subscribe today to join the collaboration. Welcome to the Collaborative Podcast. I'm your host, Spencer Krause. Our guest today is Costa NIkou. Costa is the CTO at iotaMotion. Costa, welcome to the pod.
Oh, thanks, Spencer.
Good to have you back on, buddy.
Yeah, it's been a little while.
Yeah, so last time you were here, you were representing Smith & Nephew Robotics. Now you've gone to a new company.
I mean, I think representing is maybe overstating it.
Sorry, you were speaking on behalf of yourself while employed. The views of Costa NIkou are not the views of Smith & Nephew Robotics and never were.
I think that my disclaimer said exactly that. Yeah. I was so worried. I went back and listened to it. I was like, I hope that I didn't say anything dumb that I have to pay for. I think I was okay, but I don't work there anymore. So maybe it had something to do with that.
Guilty.
You sent the unedited one to my bosses, didn't you?
I don't think we had anything bad that had to be edited out as far as I remember.
Yeah.
I mean, we talked about the King of Kong and, video games.
We did.
Starting a very successful company.
It was successful. It is a legendary Pittsburgh story. At least that's the way I'll tell it.
Yeah, no, I mean, I think it is, right? It's one of the ones that everybody talks about, including Craig, who also came on.
Yeah. Craig tells that story and it gets better every time he tells it, as they say.
Yeah, that is one of Craig's party pieces, is telling that story.
Yeah, but I lived it with Craig. It was me and him.
I like Craig. Craig's a bad motherfucker.
He is. And it was me, him, and Gabe Brisson, who was a grad student, like a PhD in robotics, like all ABD, another acronym, all but dissertation. He took a break to help us.
Wait, he just left before finishing and never went back?
Well, no, he did go back. He ended up finishing. So he did all the coursework and he was just doing his dissertation. And then we founded Blue Belt and he joined us to kind of see that through. In the meantime, working on his thesis sort of after hours. And I think at the time he was like the longest tenured PhD student that hadn't graduated, and he prolonged that by being.
How long had he been there for? Like, I think Jesse Eusetes is in the running too.
At the time, it was like 7 years at the time, and so within his class, he was definitely the front runner. I'm sure that somebody has surpassed, just because that's the sort of thing that I can imagine has a great story behind it as well.
Oh, for sure. No, I mean, they're not boring people that draw their PhDs out, right? Like, you're doing stuff, and that's why you do it.
Yeah, and so he was doing the stuff with us, and it was me and Gabe and Craig in a one-room house over in the Friendship Circle, and then
on the Blue Belt.
Close enough. I don't know if that's on the Blue Belt or not, but we ended up there. What we founded Blue Belt before we moved over to that place when we were above the check cashing place on Liberty Avenue. So that was our
awesome.
Our first spot, converted apartment building. Mr. Lombardozzi, who owned the restaurant across the street, was our landlord.
Lombardo's.
It was Lombardozzi's.
Lombardozzi's. Sorry, I thought that was Lombardo's was a restaurant, but maybe I'm mistaken.
Well, there's in Bloomfield. I don't know if they had a Lombardo's, but
I'm just a dumb idiot then. I'll take it.
But yeah. So anyway, it was a long, strange trip. We had probably 3 or 4 or 5 offices before we ended up down in the Strip District as part of Smith & Nephew, which was our acquirer and sort of carries that flag and carries the technology along. And a lot of great people from Blue Belt are still there, and I miss them dearly. It's an awesome place.
Yeah, it's a great group. Lots of good folks. I was just talking about how great some of those guys are.
Yeah.
Sounds like I should interview Reddit next, probably.
Yeah, he'd have a lot to say about Smith & Nephew and lots of other things too. So Reddit's a good friend of mine.
Yeah, he's a fun dude. I like him the few times I've met him so far.
Yeah.
Cool. So, I mean, what made you decide to go to IOTA? I mean, aside from me getting you fired.
Not to kind of dig back into the Blue Belt lore, but so our CEO at Blue Belt at the time, even though Craig was our CEO originally and a founder, we had brought in someone with a little bit more experience in sort of the big company and sort of selling companies, and his name was Eric Timko, and he was our CEO until we sold it. And one of the first things that he did whenever he left after the acquisition was to go and work with these docs over at the University of Iowa on this project they had for doing a fully implantable robot that was going to be able to adjust the position of your cochlear implant in situ after your surgery was completed. So 2 or 3 or 4 years down the line, if you needed to have your placement of your electrode adjusted because perhaps maybe you lost some more hearing and it needed to be inserted further, they were working on this idea to have an implantable robot to do that for you.
Pretty cool.
And so Eric was an advisor to them and helped them help flesh out and strategize as the company. It was founded by 2 docs out of University of Iowa, Marlon Hansen, who's still our CMO, another gentleman, Chris Kaufman, who was one of the otologists there. I think it was in his residency program. And they founded the company and did the SBIR thing and funded it and kept it alive. And I always sort of kept aware of that because of the kind of coolness of the technology. My wife is in deaf education. She's her family is her parents are deaf, her sister is deaf, and so she grew up with that. And I've been with my wife a long time, and so I've always heard about deaf culture and deaf education, and cochlear implants are always a big part of that. And so IOTA, which is a surgical robotics company focused on cochlear implantation, was always something that was interesting to me. And keeping in touch with Eric, I kind of followed along with that. And suffice to say, by the time we had gotten to the point where they kind of asked me to come join them, I had kind of run my course at Smith & Nephew. I had learned so much and had moved in a couple of different positions there, and I was just looking for something new. I have done orthopedics my whole professional life, starting at CMU, and it was really interesting to kind of think about jumping back into the smaller company area. And they made me an offer I couldn't refuse, and I signed on, and it's been great so far.
That's awesome. Yeah, no, I mean, it's really cool what you were telling me. It sounds like you guys are out at market, like you're in patients, you're at the surgeries, you're learning stuff. What have been some of the biggest differences, I guess, just kind of switching to a smaller company, kind of seeing it more? I mean, I guess you were at Blue Belt from the ground up, so that's not different for you. But the next time.
Sorry to jump in. The Blue Belt story was different in that it was the first time that I'd ever been a part of any of that and had any exposure to any of that, because I started in the lab at Carnegie Mellon. And so the founding of that company and building the technology there and innovating and incrementally building this product, or the technology and then a product and then a business, was always sort of next in line from the standpoint of where you were. This is the next goal. This is the next goal. So there was nothing to draw from your past upon. Where now joining a small company in the medical device space, I mean, the medical device space has very specific things you learn. There's a parlance, there's a sort of a strategy around product development. There's an awareness of the regulations that's what you learn as being part of a medical device company. And having that perspective and learning the lessons as I did growing up with it, like coming in where they had already had a product and they had a very lean team and they were just building processes and building capabilities. I was looking at it with a completely different set of eyes as I was back then, right? Back then I was like, oh, cool, I write this software, we're gonna sell it for $1 zillion, and it's gonna be awesome, everyone's gonna use it, and we're gonna be the kings of orthopedics, whatever was in my 22-year-old head.
You guys basically were the kings of orthopedics.
No, we were the plucky young black sheep princes of orthopedics.
That's an interesting way of looking at it.
Yeah, well, I mean, that's the thing too. Like, I think the big part of the Blue Belt story was we were sort of the underdogs. We were the small company relative to Mako, which was the big and even bigger success story from a monetary and sort of market footprint perspective. They were the first company to get bought by a major manufacturer, which was Stryker. They had paved the way for Blue Belt. They were the ones that educated the market about orthopedics or robotics in and joint reconstruction, basically knee surgery. And so we drafted behind them and benefited from them paving that way. They were also much larger, much better funded, much more, I would say, experienced group of people running that company. And from the standpoint of selling robotics and that sort of technology, our team was, pretty experienced as well, but just not in that space specifically. Yeah, and so they just were ahead, right? And so we had the pleasure of kind of basically starting to win battles head to head with essentially this gigantic, company that was 10 times bigger than us, and starting to win in the marketplace, even though we were so small and had such, I would consider kind of humble beginnings compared to where Mako had come from. And actually, so part of that success where we were able to win those deals was in part to our new CEO, Mike Lubinski, who's the IOTA CEO and is who ultimately recruited me at iotaMotion. He was the head of sales at Blue Belt. And so going to IOTA, there's a number of folks at IOTA that I worked with at Blue Belt. And so when you're jumping out of kind of the safety of a company that you grew up with the technology you understood, to some new endeavor, like it was kind of a perfect opportunity to go where you trusted the people that knew how to grow a business and knew how to do medical devices and all that stuff. So I don't know that there would be many opportunities that would have pulled me out of there. But this was a unique one.
No, you definitely were shouting the praises of Smith the whole time I knew you there.
Oh yeah, I mean, it's my family. I grew up with that. So
yeah, of course,
it was something that we built together and something that I had expert knowledge in the inner workings of. I wrote a lot of the code that was eventually in that product, and everything I learned about professional life was part of building that company. So yeah, it was a hard switch, and it was pretty emotional. It's funny, I somehow recently just found the letter that I wrote to everybody at Smith & Nephew when I was leaving, and it was like I just remember that day like being just like an emotional wreck trying to write this email to everybody. It was pretty funny to read that again. I don't know why it even popped up in my inbox, but it was an interesting discovery.
Did you know that Collaborative with Spencer Krause now has a merch store? Please go to cwskmerch.com for the latest in CWSK styles. You can get a hoodie, like the one I'm wearing, t-shirts, hell, we even have whiskey glasses. Everything in the store has custom art that our team worked really, really hard on. So go ahead and show your support for them, me, and the rest of the CWSK team by going to cwskmerch.com today. Better yet, support yourself and use discount code podcast10, all one word, all uppercase, for 10% off your entire order. Thanks for your support and enjoy the rest of the show. Collaborative with Spencer Krause is sponsored by SKA Robotics. If you're in the market for elite field robotics expertise, please consider hiring SKA Robotics. They sponsor this podcast and solve some of the toughest engineering problems in the world. SKA Robotics can be found at skarobotics.com.
So iotaMotion is super cool because, again, it's about hearing health. I'm a musician, and so I'm interested in hearing in general. I'm interested in kind of deaf communication, the technology behind it, the anatomy and the biology of the ear and how it works. As I've kind of learned it is amazing. Just the microsurgery involved in general otology and ENT it's incredible. Like the sorts of things that they do, it's amazing they ever had any idea that they could do any of it based on coming, in the side of your head and drilling down and finding the hole that's going to get you into your cochlea. If you look at the anatomy, it's like, how did they ever think that they were going to be able to pull this off regularly, originally without imaging and all that kind of stuff?
They did it without imaging at one point?
Well, I mean, I would imagine so. Like the imaging.
What was the first cochlear implant?
I want to say, I should know this. I'm a bad CTO.
I am.
But I mean, the 80s, I think, was when they started to have the original.
But I mean, they had X-rays in the 80s, right? Like, I mean, there were.
Yeah, but I mean, they didn't have like sub-millimeter CT scans that they used repeatedly to look at things. Like, it was an anatomy-based sort of exploration where they knew from doing general anatomy that they could reach these things.
Supposed to be here.
But to think about, so when you do the surgery, you drill through the mastoid, which is the hard bone behind your ear. So that little piece that kind of juts down kind of right above your jaw.
Got it.
They drill down and they somehow navigate their way through sight and feel through sort of the bone, avoiding the facial nerve so that they don't paralyze your face, and making a little hole that somehow gives you access to both the bones of the inner ear as well as the round and oval window membranes to the cochlea. And then they make a little slit in the round window, or they make a little extra hole next to it, and then they feed this electrode in by hand, and it winds its way up.
When they had to know that was going to work, which I'm sure was
right. So like, how do you even think that you're going to be able to take this all the way
to get that?
Yeah, and it's interesting if you look at the history of the design of the devices, where it was like it used to be one electrode and something like a Sony Walkman size thing that you wore on your hip all the time. So it was basically just. I'm sorry?
That's where your ear was.
Well, that's where your...
An amplifier, I would think.
I mean, it was all about amplification. So I don't know. I don't remember where.
The microphone might have been placed somewhere else.
I don't remember if they had a separate earpiece for that to localize it, or if at first it was just sort of like on the unit as well. But just to think that they could pull that off, right, and then decide they're going to make a couple of electrodes and they're going to miniaturize it, and then now they have it so that most of the devices inside of your skin, and then there's the kind of receiver, stimulator, or wireless communication.
That's the thing that just sits like right over there that you see on people sometimes.
Yeah, so there is something that's kind of closer to the back of your head that is kind of the magnetic coupling between the outer earpiece, which has the microphone, and I think the processor, and the kind of wireless communication that goes through the skin to the receiver stimulator, which is the thing that's actually zapping the electrodes that give you the electrical impulses that trigger your hearing sense. And so there's processes in there basically turning the sound, doing crazy FFT stuff according to some programming pathway, and basically stimulating the inner ear in the right patterns according to a programming step that happens as part of your therapy to make it
interesting. So you have to like localize it and see how it responds to your body to get the frequencies right.
So you put it in, and they kind of go where they go, right? And there's a series of 12 to 20 electrode pads that go into your cochlea. And essentially, the deeper you go into the cochlea is the deeper the lower the frequency.
Oh, interesting.
So if you think about how low frequency sound travels over the broader distances rather than high frequency, which are shorter distances. And so essentially your cochlea is like a giant drumhead that's curved into a shape of a spiral.
Yeah.
The vibrations vibrate the basilar membrane, which is the drumhead, and it stimulates the hair cells in there that turn them into sound, and your brain does the FFT, the reverse FFT, to turn it into whatever your neurons treat as hearing. And somehow biology and evolution has made this perfectly compact little snail-shaped thing that make that work and make hearing our experience. Like,
yeah,
it's amazing that number one, that it works at all, that number two, that we figured out how to sort of like short circuit literally the process with the levels of hearing and performance that they get now, where children are implanted with cochlear implants, basically you can't tell that they've had any hearing loss in a lot of cases.
That's awesome.
Yeah.
That's really, really cool. So just to, I mean, this is me being a total nerd, but to understand the geometry, the reason I thought higher the further in you get is because it spirals, and I figured shorter distances, therefore higher frequency. But
no, so the outer part is the higher frequency, and that's sort of what you typically lose first.
Okay.
And then so as you go deeper, it is the lower frequencies that kind of go into the inside. We think about longer tubes, right?
Yeah.
So longer resonance tubes will be lower tones.
Yeah,
right?
that makes sense to me.
Right. Basses are bigger than violins.
That makes sense to me. But
So-
then again, like in my mind, if I think of like a spiral, I'm thinking like there's going to be longer distances around the
Well, so
outside of it.
don't think of a spiral, because think of it as a spiral. It's a tube,
Yeah.
right? So the higher frequencies resonate closer, and the waves travel further along the tube better. And so as it's sort of it's basically self-selecting the frequencies along on the way.
Which is amazing that works, like you said, just from like evolution and
Yeah, just amazing that the sound that we experience in our just general hearing function, and the richness that we bring to sound, that is seemingly universal. And I think the craziest thing to me is how common the anatomy is in that particular way, where generally you can drill in from here and find the cochlea in a shot where the same cochlear implants work for everybody. The same surgical techniques generally works for everybody. There's anatomical variations,
well,
but
it sounds like there's calibration to get the frequencies right.
well, so depending on where it is and of course your own biology, you have to figure out the best frequency
Yeah.
that aligns to wherever the electrode ends up inside
So
of your
imagine you
cochlea.
just play different frequencies at someone and you see where they hear them, and that's how you calibrate it.
Yeah. So I mean, in some cases there is pitch matching. If you have existing hearing in the other ear, right, you could do pitch matching so that they
that's
can
cool.
make it so that you're not getting two different frequency spectrums in
But if
either
you
ear.
don't, then you just kind of map it where you map
If
it.
you don't, if you have memory of hearing, so you can say, "Oh, that sounds really high pitched." Like some patients,
and
they
they'll adjust it.
they
yeah.
can adjust where any of the particular sounds kind of trigger.
Pretty cool. But if you've never had hearing,
if you've never had hearing,
it's just kind of like subjective.
Yeah, and it's probably
And your brain will map.
your brain maps, right? It becomes
Yeah.
plastic, as opposed to if you grew up with hearing and you just sort of lost it, then you've got to kind of like take advantage of the organization that's already there.
Yeah, that makes sense. But if you're just getting it for the first time, then your brain will figure it out, and you're gonna
Yeah.
not
Yeah.
get hearing. Which
Yeah, I don't know the nuances in programming for, say, someone that's profoundly deaf, or in children where everything is, everything, your brain is goo at that point, right?
Yeah, exactly.
But suffice to say, the earlier you get them, the better, at least it seems, and the better success you have in getting the same experience that you would have otherwise.
That's interesting. And because you've got the magnetic coupling, does that, I mean, assuming you don't need like a battery in it or anything, like
The battery's in the outer piece,
that's awesome.
and then it translates
So
signal
you
to
just
power.
have one when you're a kid, and then you can have it for decades, and
Yeah.
just have different outer pieces that couple to it.
Yeah, there are implant upgrades like over the lifetime of a particular patient that they end up getting for sake of technology improvement. So, for instance,
Like
you can get
surgical upgrades, or do you keep the same internally and they do external upgrades?
sometimes you get explant, but most of it is external upgrades.
Yeah, that makes sense.
Yeah.
That's interesting.
Yeah, I mean, it's fascinating. It's
Yeah.
um,
There's a whole world I know very little about.
Yeah.
Obviously, I mean, I didn't even know which way was high versus low frequency.
well, I mean, how much do you think about sort of the
I
mechanics?
don't know what the anatomy of it. Like, I think of a spiral, but that's
Yeah.
a really dumbed down interpretation.
Well, and that's just part of it. That's just the inner ear, right? So just the middle ear with the bones and the way they work. And one of the things I learned, actually, ironically, as I was interviewing a potential intern after I knew I was leaving Smith & Nephew, I was at Smith & Nephew, we were interviewing a guy. He was talking about middle ear replacement implants. So if you had, so there's the hammer, anvil, and stirrup, right? As we learn in school. And if there's some loss of connection or some malformation or something, I don't know enough about it to speak intelligently, but you can replace those with little tiny metal implants. They make tiny little stirrup implants that you can replace so that you can help restore the mechanical chain that bangs against your ear.
Oh, that's pretty cool. So it's
Your
totally
inner ear.
passive.
And so you have your eardrum, and that vibrates the hammer, then the anvil, then the stirrup. And if there's some break in that chain because of something,
Yeah.
you can actually, they sell implants that will replace those tiny little bones, and you shove them in there, and they regain the chain, and that's how the oval window gets vibrated.
Oh, that's really cool. I would imagine getting that positioned correctly is challenging.
You would imagine that would be so hypercritical, but apparently you can do it. It's so the journey going from orthopedics, where I sort of incrementally learned about the anatomy and the business over 20 years, to be thrown into a completely new world of a completely new anatomy has been super fun. And the surgeons are awesome people. Like, not that orthopedic surgeons are bad people, but it's a totally different vibe. It's a totally different vibe. I had a friend of mine who was an MD PhD in the lab, and he says when you go to med school, you kind of find your tribe. He ended up as a spine surgeon because they were like the kind of the techie car guys, where orthopods.
Orthopods are the carpenters, effectively, mechanics.
Yeah, well, they have a reputation for being sort of mostly the jocks,
That too.
right? And
My dad was always a huge jock. That's 100% true.
Yeah.
In his case.
and otologists just seem to be a little bit more mild-mannered and a little bit more reserved, and although there are some guys that are clearly athletes, like Dr. Hansen is a big dude and could probably throw you over a barn, but sweetest guy, and learned a lot from him in my short tenure there. So it's been great kind of learning a whole bunch of new stuff. Like my first 6 months was like, my brain was like, wow, this new stuff. It's all crazy. So it's been really cool. And then seeing the parallels between sort of the blue belt story and orthopedics, and so the dynamics of the market and implant companies, and how there are things that are totally different, but things that are almost exactly the same, where we're a robotics company trying to help put in cochlear implants as opposed to orthopedic implants. And there's these three major manufacturers in our world, where in orthopedics there are 4 major manufacturers, and you're building a system that could put everybody's in. But then there's always the pressure to like, well, what if we should put one, or should we make our own implant? Like the same questions from 15 years ago come up again. It's like, oh my God, we're here again.
Deja vu.
I can't believe we're having this conversation, right? I will say that making a cochlear implant is probably a little harder than making an orthopedic implant, just because there's so much sort of precise trade secret
You
sort
guys
of
did
technology.
make an ortho implant.
Oh, we did.
You did?
Blue Belt, we had
I
a
didn't realize
implant.
you guys had your own implant.
Oh, we did. So
I did
that's
not know that.
So that's the
I'm
thing,
sorry
right?
about that.
Well, I mean, that's not a big part of the story, but it was a necessary part. So with Blue Belt, the first idea was we're going to make this technology. We had technology license out of CMU. We had the ability to sort of incorporate this into all the surgical navigation technology. So Medtronic and Zimmer and Smith & Nephew, there are these companies that already had orthopedic navigation where the cameras would track things and you could put guides to guide your tools, but none of them had robotics. And so we had this technology that was a robotics technology. The tracking technology was the same. All you could do is you could plug this into your navigation system and have smart drilling, which is what we were doing. So, so Smith & Nephew's technology was the precision freehand sculpting stuff out of Carnegie Mellon, where the drill was smart enough to know when to cut and when not to cut based on the shape you were supposed to make. And so you could export that to anybody that wants to cut bone. We tried spine companies. We tried cranial companies. We had grants doing all different sorts of things. That's how we stayed alive. But ultimately, nobody was willing to bet and try to do that integration work themselves. And so the end of the early days of Blue Belt was when the private equity group that sort of rescued us, bought us out, said, you're going to make a product. You're going to get FDA approval for an orthopedics robot. And so we had to take our technology, which we had been building to export to other people. We had to become our own customer. We had to build the product around that. And so, from 2004 to 2012-ish.
You were working on?
Yeah, so 2004 to 2012, it was all technology development, make it better, chase another application, demonstrate the concept. Starting in 2012 was make the product, get the FDA approval, build orthopedic application around it, stop messing around with spine and cranial and chasing stupid funding, doing augmented reality side projects to keep the lights on. Here's a few $1 million, make us a product. And so that's what we did. So that became Navio. Navio was the result of that group becoming a medical device company, not becoming a technology company.
Yeah, makes sense.
And so we had to get the FDA approval. And so we got the FDA approval. We actually partnered with a Western Pennsylvania company, Stelcast, who had an implant. They were the first implant. I think that's what we used to go and get our 510K application to prove that we could do surgery with a knee implant. So they gave us the CAD. They were very nice in working with us. I think we put in a half dozen Stelcasts over the years. And then we started to shop around and work with other large companies, right? Stelcast is a totally legit company, but they were small. They were a little bit more boutique. This is where we were going to the Johnson & Johnsons and Zimmers and things, and we were trying to set up product development, research projects to basically prove our worth to them. And we did a lot of that. We did everybody, the major manufacturers other than Stryker, who, like I said, had their designs on the other company. And
Mako.
Yeah, so the Mako robot, this is Stryker Mako. Mako, before Mako was a product, Mako was the company that Stryker bought to put their implants on with. And so, like I said, they sort of paved the way for us. But we only had limited success there because we weren't a threat to anybody, right? Everybody could work with us. We could put anybody's implant in. But in order to show that we could survive on our own, to show that we were a threat to orthopedics, we were going to be able to, quote, disrupt orthopedics, we needed an implant. So we developed our own implant. And the implant was unique because it had a curved surface on the back instead of flat cuts.
Oh, interesting.
Because we could do that with a robot. And so not that we had any sort of proof that was better in any way. It certainly was cooler. And my dad has 2 stride implants. So my father has 2 partial knee implants, 1 in each leg, Blue Belt implants.
Oh, that's awesome.
Yeah. The X-ray is one of the best things.
So cool.
And he's, you would never know, other than, he's in his 70s now. So he's just generally puttering around as opposed to because of his knees. But my dad was on ladders and he was a painter. And so he's a fearless guy. He worked sandblasting bridges and stuff when he was in his
That's awesome.
early days. And he's been on a ladder ever since. It's hard to get him to not go up high and do crazy things that you don't do with knee replacements. He's got 2 Navio strides, and Brian Hamlin down here at McGee did both of his knees.
That's awesome.
And we worked with Brian in the early days. He was a great great advocate and partner with us in the early blue belt days. So I was happy to send my dad to him.
Nice.
But again, we had to make our own implant to prove the capability of Navio and show that we were a viable thing, right? That we were actually moving product. And then we had to do the same thing with the total knee implant. And we had the total knee implant. What was the name of it? Gosh. I think we put like 2 in. I don't even know if we put any in. We may have done the total knee to prove that we could do it to get the 510K, and then that's when Stryker bought us. Or sorry, Smith and Nephew. Smith and Nephew came in and bought us.
No, sorry. I should recognize that too.
Yeah. That was sort of the last thing. And actually, we didn't have approval for the Smith and Nephew implants until after they bought us, of course, and that was the long way. But again, you had to flesh it all out, right? It wasn't enough. These companies were risk averse enough and secure enough in their own worlds to not bet on a technology. They needed to see it, as we were talking about a little earlier today. They had to see it real. They had to,
So you had to
build the
make
whole
those
thing.
implants in order to demonstrate.
Yeah, we just couldn't get the traction with someone else's implants.
Yeah.
And so we had to go it alone. I don't remember the specific conversations, but we did it.
That's awesome.
And and you could imagine what sort of a right turn that is, and a major investment for a company that was, a
For sure.
software robotics
All the
company.
way
Like,
to the point where it's in your dad. I mean, like that's.
yeah, it's cool, but I mean, it was something that we had no expectation or any experience really building implantable devices in that way. We were kind of a
Yeah, I had no idea you did that until now.
Yeah, we had to make the trays. So it's not just the implants. You had to make the whole instrument tray to put them in. You had to prove you could put them in with the instrument trays as a backup to the robot in case the robot didn't work.
Yeah, that makes sense.
And so it wasn't enough to just say, yeah, robots can put it in any shape. It was like, nope, robots can put it in any shape, but you have to support this as like a complete implant system that you could ignore with a robot.
Do that contour without the robot.
You make bigger cuts than you need to, and cement fills the rest.
Oh, that makes sense.
Yeah, I mean it was fine. It was good enough. But yeah, it's crazy. I think we probably made extra cuts. So knee implants are typically 3 or 4 cuts, and so it's fairly prismatic looking.
Yeah.
With a curved contour, we can make a few extra cuts and round it off enough for the cement to do the rest.
Yeah, that makes sense. You probably have like an 1/8 inch gap or something, but it's close enough.
Yeah, and I mean a lot of the cement is good and it works fine, and people rely on it. So it wasn't a problem, but yeah, it's a not everybody knows about that, actually, probably within Smith and Nephew, that we had our own implant. But it was a huge deal at the time for us to have to make that, and it was, like I said, a total left turn for us as a group, and something we had to put a lot of money into.
Yeah, I can only imagine. I mean, I've never had to do that.
Yeah.
Although SKA is working on a medical device right now, so that's exciting.
Yeah.
Yeah, and that's all I can say about it on the air.
That's all you can say.
Yeah.
What body part? You can't talk about the body part?
Can't say what body part.
Oh.
Not yet anyway, but
All right.
soon hopefully it'll be out and we can get more into it.
Hopefully it's an interesting body part.
Yeah. Awesome. So, what do you think is next? Like, are you, I guess, working on any new devices at IOTA? Like, do you have eyes on any other like things you want to work on?
Well, so right now we have
Goal to become a world champion Donkey Kong player.
Well, I will say we have, and this is public knowledge if you can mine the NIH database, if that still exists. Thanks for the new innovations in government funding and management. We have an active SBIR grant where we're kind of rounding down, where we're taking a robotic insertion and adding sensing capabilities. So there's this thing called electrocochleography, which is this whole other thing, which is amazing. What they do is they play tones in your ear while they are inserting the implant.
Huh.
And as the implant is going in, they can have the implant not just be sort of a receiver for sake of the processor that generates your hearing impulses, but also as a way to look at what the ear is doing. There's a sort of microphonic response that's happening. When you play tones, your ear is biologically reacting to that, and you can pick up those electropotential changes using the implant itself.
Oh, that's interesting.
And so you can monitor the ear's response as you play tones, as you're inserting the implant. And so the way they do this now is they feed this in manually. I guess I didn't really say that, like, iotaMotion is solving the problem that humans just can't go slow enough when you're doing an implant. Like, basically they use tweezers, they feed the implant by pushing it in, and they're limited by human dexterity, right?
Yeah, that makes sense.
And so if you're shaky when you're going in, you're creating all these pressure waves that are like giant loud sounds that can, be traumatic to your hearing, any residual hearing that you may have. And so our whole mission is to eliminate any of the variability in human insertion by using robotic insertion.
Yeah.
So I probably should have led with that. I apologize. But that's what our mission is.
In sooner.
Oh, you keep talking about Smith and Nephew, and he's drumming up the past, making me all nostalgic.
That's interesting.
But anyway, the robotic insertion is great. We have results that show that you can reduce the trauma in insertion. Histology shows that we've done a better job in not damaging the ear on insertion. But if you can be responsive to the actual listening to the ear, if that's a thing, while you're inserting it, you can be better at that. So, our SBIR grant supported development of a combined system where you have electrocochleography informing the insertion process.
Huh.
And so this is only stuff that has sort of just started to be in research, but, as part of the small business program, we were able to develop this as sort of a product capability. Now,
That's pretty
we won't have approval for that, but we've demonstrated, and we're doing it in clinical trials right now.
That's awesome.
And so that's super cool.
It is that dials out some of the variability in the calibration at the end, so you get more like longer tail on the lows and the highs because you're not off by it.
Well, so part of the reason I use electrocochleography is that when you're pushing the implant in, and I'm going to use really coarse terms for sake of explanation, if you push it in too far, you kind of cram it up against the basilar membrane, and you're pushing against the membrane that carries the sound into the cochlea, right? And so that's traumatic, but also doesn't help your hearing at all, because the hearing is aided by electrical impulses. But natural hearing still has to rely on the vibration of the inner structures. So if you're shoving this thing in too far, and you don't know how far you shoved it in, you don't know how tight anybody's cochlea is relative to the implant. They have CT scan based planners that can kind of give you a rough idea, but it's like a noodle. You're shoving a piece of spaghetti into kind of an unknown spiral.
Yeah.
And you can't really feel when you've gone too far until you've gone too far, right?
No.
And what electrocochleography lets you do is know that you've gone too far if you see that the response of the ear drops off. So if you're pushing this in,
Just come back out at that
and
point?
then so there are published techniques that show that if you see a drop, what they say a drop in the ECOG signal, you can pull it back some amount, and if you see the hearing respond accordingly, so that if the signal comes back, you leave it there. That's where you leave it, as opposed to shove it as far as it will go and sew them up, right?
Yeah.
If you go in and you say, oh, it's dropped, I'm going to pull back a little bit. You see the signal go up and you go, that's perfect. And I believe that the papers actually show that there is a long-term benefit to that technique.
Oh, cool.
And so you can do that manually, right? Because you push it in and then you see it drop and you bring it back, right? But what kind of trauma is done in part of that process?
Sure.
The robotics and the integration of the sensors and the ability for things like
Peak before you go to.
to use machine learning to figure out what those peaks really mean, like the potential for sampling more than 1 or 2 or 3 or 4 electrodes, sampling all the electrodes in combination, looking at hearing holistically as you're doing robotic insertion is super interesting and compelling, right? And so we're on the first step of that, of just connecting the systems. But the future is going to, of course, be that there's some algorithm that's watching and it knows what the expected pattern is of hearing as you do an insertion, and it's going to optimize that placement.
Do you factor imaging in as well at that point? I mean,
So I think the imaging has a lot to do with just understanding the geometry of your cochlea. You can look at, there's amazing kind of photon counting CT scans that you could look at, like microstructures. But at the very least, with standard CT imaging, you can look at the size of the cochlea as it narrows into the spiral.
yeah.
You don't want to put an implant that's too big and too long to support that. And so
Right,
they're
makes
starting to build surgical planners and techniques that will allow you to do a better job of right sizing the implant and right sizing the procedure for a particular patient. They're still sort of in the early.
Do you do live imaging when you insert the implant, or is the imaging done just beforehand to size the implant? And then
It's
you
only
find out-
typically it's only beforehand. You could do like fluoroscopy or cone beam CT
Yeah.
in the surgery, but typically they only do that if they think that there's a problem, like if the implant folds over on itself. and they want to check that as sort of a
Figure out what's
safety
going
check.
on and fix it. And
Yeah.
then we'll introduce
Yeah.
fluoroscopy.
But those are only in more, I would say, extreme cases.
Yeah.
Run-of-the-mill cochlear implant surgeries are
Why
not
wouldn't
doing
you just
live
do that
imaging.
every time? I mean, just out of curiosity.
Radiation costs.
Yeah, it makes sense.
You're just constantly irradiating a patient.
Yeah.
To check this thing, they tend to avoid that.
Yeah, makes a lot of sense. Just curious.
But yeah, I mean, it's you know, it's one of those things where it's like, why isn't this free? Like, why isn't that something you always do? If you could protect the patients and you can have a better surgery, you could dial down the radiation. But I just think that the amount of care to optimize the imaging pathway in general.
Well, there's other ways to figure it out where you don't have to irradiate the patient.
Well, I think that, yes. I mean, you can use external technologies.
Or what you were talking about with just the playing sound. I can't remember the name of it.
Oh, electrocochleography. Yeah. Yeah. And there's other sensing techniques with different implants, and they all have the different systems. But, using your eyes to kind of see what's going on is always beneficial too. And so if you had, for lack of a better term, live x-rays all the time watching yourself do the surgery, you'd probably do a better job. You have more information. You can't always do that. You can't have a constant radiation stream, but certainly a lot of procedures would benefit from more imaging. Like for instance, knee surgery would probably benefit from more imaging. You have a better picture of the knee. You just have to optimize the radiation so that it's not harmful. And doesn't build up over time, and protect the staff and protect the surgeons and minimize it for the patient. But then you could make custom implants and all that sort of thing. The system doesn't support that from a cost and a technology complication and time spent on all this stuff perspective. But I mean, the technology is all there to make possible a more sophisticated procedure. Just the economics and the healthcare system doesn't support that.
Yeah, it makes sense.
And then, the value add of all that is still, we don't know.
Not worth the expense.
Maybe, but we don't know.
Yeah.
Because nobody's building a system that is like a perfectly bespoke knee implant for you with the level of research to kind of prove that it's the case.
Yeah. Well, and how would you even see returns to scale on something like that? I mean, I guess.
Yeah. I mean, a well-done knee replacement, you do really well, right? A poorly done knee replacement, you don't do so well. They're still having a hard time getting that right. Squeaking out the last 5% of optimization for your particular anatomy that's different from, say, just the generic size and shape of that size of an implant for you is still unknown. And maybe people that work for companies like the custom implant manufacturers might argue with me on that. I don't know what data they might have. But knee implants sort of look like knees, right? They're pretty close. They designed them to be pretty close. To me, my experience tells me that it's more about the surgeon's ability to put them into the right place than it is the shape of the knee implant.
Yeah.
And there's a long way to go to make sure that all surgeons are doing a better job with that.
Yeah, it makes sense.
Yeah. And so we were talking about electrocochleography. That's one of the things that we're working on in IOTA. Another thing is just a general new platform. Right now, iotaMotion supports only straight implants. And I do this because they're straight. And they're like a floppy noodle, and you push them in, and they go where they go. There's another class of implants that are pre-curved, meant to sort of hug the inner surface of the cochlea. And so they use either a tube or a stylet as a straightener, and you put it in there, and then you push the implant off, and it sort of goes in a curved pattern.
That's pretty
Now, that's cool.
like the skewer and like a tempura shrimp.
Yes. I'm going to have to think about that next time I get some tempura shrimp. Although they kind of, when you fry them, they stick that way. As opposed, they don't recurl.
But only if you put a thing in the middle.
Right. But if you pull the stylet, if you pull the skewer out, they don't curl back up.
Yeah. You just got to cook it.
Yeah, I guess they would curl if you didn't cook it. No, I want some tempura shrimp.
They're very good.
Yeah, they are. It's totally derailed my train of thought there. And so there's a whole other class of curved implants that are meant to hug the cochlear shape better, right? Straight implants sort of follow the outer wall of the cochlea, and they're forced to go in the curved pattern. These implants want to go in a curved pattern. Yeah. And so they get closer to the nerve endings, which are on the center of the spiral. They're on the medialis is the center part. So,
awesome. So they're somewhat more efficacious?
That's the idea. But there's one shape of the spiral, and everybody has a different spiral. In fact, the spirals are all planar. Everybody's it's a helical curve, but the implants are all planar, probably for sake of simplicity in manufacturing and universality. Like dealing with left versus right cochlear implants is probably a huge pain in the butt for the industry, even though it would be more efficacious from the standpoint of matching the anatomy. But everybody has a different helical curve, and so maybe flat is just fine and probably all we can handle right now. But right now, iotaMotion doesn't support that class of implants, but it's roughly 50% of the market.
Yeah.
So we are interested in that part of the market because we want to serve everybody. We want to do every kind of implant. We want every surgeon whatever their predilection. We want to support every audiologist that wants to do right for their patient. And so that's on our big agenda. And we've got some really cool things in store for how we're going to do that and how that affects the greater platform for all implants, not just curved implants.
That's awesome.
We're very excited.
Yeah, I'm excited too.
Great.
All right, so as we end, I always ask, is there anything you want to plug, toward the end of the episode?
Nothing specifically that I haven't been plugging. So like I said, we're very excited about what we're doing at iotaMotion. If you are interested in, technology that directly affects lots of people and has the opportunity to help a lot of folks, please check us out.
How can I check my hearing? How do I get at that?
I don't know. I don't have a URL that I can quote to you. I'm sure if you search for hearing test apps, I know that at least the Google Play system has 2 or 3 of them available if you search for hearing test app. Like I said, I think it's Hearing Health Month, and so there's probably a lot of stuff out there for March. Look for iotaMotion on LinkedIn at the very least. Our social media campaign is talking about that. Like I said, you don't know until you know, and you may benefit from some help.
And if you don't know, now you know.
Yeah, and if you don't know, you know.
Thanks for coming out.
Good to see you.
You too, buddy.
Thanks for joining us today. If you've made it this far, chances are you'll like other episodes too. Collaborative with Spencer Krause is available on YouTube, Spotify, Apple Podcasts, Google Podcasts, Pocket Casts, and Radio Public. Subscribe today to get notified when the latest episodes release and support the channel. Collaborative with Spencer Krause is sponsored by SKA Robotics. If you're in the market for elite field robotics expertise, please consider hiring SKA Robotics. They sponsor this podcast and solve some of the toughest engineering problems in the world. SKA Robotics can be found at skarobotics.com. Thanks again, and see you on the next one.